Hello. Today we're going to talk about Saltstack and how it applies to the Dimension Data Cloud. Saltstack is an open source software for modern IT automation. Very popular tool in the DevOps world, similar to Puppet Chef and Ansible that you might be familiar with, or at least one of them. It has a number of capabilities. It's definitely grown in popularity and is heavily utilized by internet scale companies, where you may have tens of thousands of nodes or even hundreds of thousands of nodes, and performance of managing those servers or assets, cloud assets perhaps, it does not diminish by scale. So it's a very powerful tool that has a very differentiated core engine built on a message bus that provides that capability of managing scale. The first feature that we have for Saltstack is, or a unique feature, is that it can be run in agent or agentless mode. So that definitely opens up a lot of possibilities. And you can deploy software through bootstrap mechanism. Actually, this is all handled through the master, and just so it's more of the underlying plumbing, where it may install an agent, or it can actually work directly through SSH without an agent on the managed server. The other aspect is of cloud automation. So Saltstack leverages an open source library called Apache libcloud, and it's a library that was built as an abstraction or layer for integrating with multiple clouds. So it has a common interface and allows you to interact with any cloud out there, or at least most of the popular clouds, and leverages some of the work that Dimension Data has done to integrate with Apache libcloud, and essentially Saltstack pulls that in and then provides that native capability to automate resources or provisioning of resources on the Dimension Data Cloud. Configuration management is certainly a core feature of DevOps. So Saltstack provides a very verbose, very capable set of tools to deploy software, to manage, to bring servers to defined state, and it can allow you to do this either imperatively or declaratively. And finally, remote execution is based on that agentless architecture. You can leverage Salt SSH to execute commands remotely over thousands of servers and without any significant or visible performance impact. So that's kind of a high-level overview of Saltstack. And so let's take a little bit closer look under the covers. So you can see a lot of different pieces here. I'm not going to cover a lot of them in this session, but at a high level, I'm going to mention is that Saltstack is a server agent architecture, where the server is referred to as the Salt master, and the agents, which are actually deployed on the managed servers, are called Salt minions. So the minions are the servers. For instance, if Salt creates servers on the Dimension Data Cloud, those servers become minions of the Salt master, and they receive commands simultaneously. It's almost instantaneously without any delay between commands across the board. And those commands can be executed locally, and then the results of those commands are reported back to the server or the master. The communication takes place over a high-performance data pipe. So there's an option to use different configurations, but by default, I believe it uses 0MQ, which is a messaging protocol. And there's also another one called raw with the Tornado. That's their Saltstack's own implementation over raw TCP. This provides a lot more efficiency and reliability beyond just standard raw TCP. And of course, there's SSH as well to communicate when you have an agentless deployment. Security is handled using PKI, public key authentication. So when the minions come up, they are going to communicate with the server, and the server is going to authenticate those minions using a public key. And the encryption or the payload that is passed back and forth between the server and the minions, or between minions themselves, takes place with using AES encryption. And lastly, one of the main features, of course, that is part of the configuration management is SLS files, or what Salt talks about is Salt state system, right? So that's really the core engine that is responsible for parsing these files and executing those commands, or all the logic that's contained in those files. And it's all YAML based, so that should be familiar. I think that's the same. YAML is yet another markup language that's used even in Ansible as well. So it's definitely a very useful and cross-platform language. So finally, one last thing is Salt is based on Python, and so when you write custom plugins or extensions, you can easily write them in Python. In fact, the work I had to do for this demo required extending some of the Saltstack native integration around dimension data, and that required writing some of the extensions in Python. So they make it very open and very convenient to integrate a lot of different features and capabilities and third-party integrations. Okay, so I'll just give you a quick context as to how the demo is set up. This is just a high-level overview, and we are going to leverage the link at the bottom, which is a README file, and that README file has all the step-by-step instructions on how to replicate the demo. In fact, I'm going to follow that for the most part as well. So even after this video, you can go back and replicate this demo for your own learning purposes or a demonstration. So at a high level, what we are going to do in this demo is we are going to leverage Saltstack, and we are going to leverage two modules of Saltstack, or I should say commands of Saltstack. One handles all of the cloud operations, and the other one is a reactor command or a module. And what that handles is the event system, or the event orchestration. So I'll talk about that in a second. So on the left you see this box, and that box with the Saltstack icon on the top left is essentially representing an entire machine or a server that has these components sitting on them, and that server is called the Salt Master. Now, and in the middle we have a Dimension Data Cloud, and you can see a few servers that represent VMs that are going to be created and deployed and configured with software. Now on the right side you see what's going to actually be the end result once everything has been done, which is really a browser test to see if the HTTP server is up and running on one of these servers. So let's follow steps 1, 2, 3, 4. So what's happening here is that when you execute the first set of commands, which you will see in the README on the GitHub repository, we are issuing a set of commands that will invoke the Salt Cloud command. And what that does is it's going to read a set of configuration files, and using those configuration files, and those configuration files are specific information around the cloud resources, the cloud provider, and how those resources need to be created. So the Salt Cloud command is going to issue a provisioning request on the MCP, or the Managed Cloud Platform for Dimension Data, and it's going to spin up 3 servers. Once those servers have spun up, it's going to be communicating status back and forth, and we'll see that in the demo on how that happens. It's using the event bus, right, to talk to the Salt master. So once the Salt master receives the events that it has subscribed to, and that is really using the capabilities of the Salt reactor, right, that you see in the top of the box. So the Salt reactor is listening for certain events, and once those events have come up on its topic, it's going to issue a set of commands that's going to read some of the SLS files, which are the Salt state files, and those are essentially those files which have all the configuration set of commands that have to be performed on the minions, right? Remember, minions are the servers that were provisioned on the Dimension Data Cloud. So as soon as those events show up on the reactor, it's going to execute those Salt state files, and that those Salt state files basically are doing things like just some echoing of certain information into a log file, and also invoking some subsequent Salt state files or SLS files to install HTTP server and bring it into a managed state. Okay. So once all that happens, and this is all happening in one shot, as in programmatically automated fashion. There's no intervention required once this is all set up. And once all those servers have been configured and installed with Apache HTTP server, on step 4, we are going to launch a browser and point to any one of those IP addresses of the servers that were provisioned on the Dimension Data Cloud, and you should be able to see the HTTP server test page in your browser. One important thing that I forgot to mention is that we are doing this over the public internet. So, and I'll talk a little bit perhaps in the demo later. So currently in the Saltstack release stream, you can't do this over public internet. You have to be on the Dimension Data local VLAN, that is the Salt master, and it can only spin up servers within the VLAN. So as might be apparent, there were some networking features or capabilities required to talk to the VMs over a public internet. You have to obviously create firewall rules and natting and all that stuff. So now that capability is in there in the development stream that's used for this demo, and hopefully we'll have that pushed into the main release sometime in the near future. That's all I have for a high-level overview and introduction of Saltstack and the demo that we're going to do in a few moments. Thank you.